Hi there, Mr. Muhammad is here. This is Revised for Checkpoint book, Unit 9, Pythagoras Theorem. This is the objective of this tutorial. We're going to focus on Pythagoras Theorem to find the missing sides in right-angled triangles. Remember, Pythagoras works only when you have a right angle in the triangle, so it is only on right-angled triangles. And the rule is like this: the longest side, which is the hypotenuse square, is equal to the sum of the other two sides square. Here, a square is equal to b square, this side, plus c square, this side. Now let's go to the exercises. Here, exercise 1, b is 5 centimeters, C is 12 centimeters, A is missing. To do this, we can start by writing A square is equal to B square plus C square. Okay, then A is missing, it stays as A square, which is equal to B is equal to 5. So it is 5 square plus 12 square. Now A square is equal to 5 square is 25 plus 12 square is 144. If we add them together, we get 169. So A square is equal to 169. But what is missing is only A, it's not A square. So how can we remove this power 2? How can we get A alone, not A square? By taking square root of the 169, we will get A. Then A is equal to the square root of 169, which is 13. A is 13 centimeters. Question 2. Question 2, B is 15, C is 8. To do this, B is 15, C is 8. Again, A is missing. We're going to follow the same steps. A square is equal to 15 square plus 8 square. 15 square is equal to 225 plus 8 square is equal to 64. 289. A square is 289. What about just A? A is the square root of 289. 289, which is equal to 17. And A is equal to 17. So here, the missing side A is 17 centimeters. So it goes like this. If we look at question 7, you see two sides are the same. It means we have an isosceles triangle, and at the same time the isosceles triangle has one of the angles 90, and the other two angles must be 45, 45. But anyway, because it has a right angle, we can use Pythagoras. Then again, A square, which is the hypotenuse, is equal to 7 square plus 7 square. And 7 square is equal to 49 plus 49. This is equal to 98. Well, A square is equal to 98. What about just A? Just A is the square root of 98. The square root of 98 is 9.89. We can simply say 9.9. A is 9.9, so that's it. These exercises were about the missing hypotenuse. But what if we have one of the shorter sides missing? When we have something like this, let's say in this triangle, the side is 6, the side is 2, the side is missing. How can we get benefit from the Pythagoras? Since we have a right angle, Pythagoras is applicable. Now, 6 square, which is the longest side square, is equal to 2 square plus the missing side, let's call C. This is C, missing. Okay, 6 square is 36, is equal to 2 square is 4 plus C square. Now, to have C square alone on this side, this 4 will go here, or we can straight away say C square is equal to A square minus B square. For any shorter side, the Pythagoras looks like this. B square will be equal to A square minus C square, and C square is equal to A square minus B square. Since C is missing here, we're going to follow this. 36 minus 4, C square is equal to 36 minus 4. C square is equal to 32. C is the square root of 32, which is 5.65. C is 5.65. Rotation, reflection, and translation. This worked example is very good to check your understanding. Then let's go to the exercise 1. The diagram shows a triangle T, this black one. The image of T under 3 different transformations are shown and labeled P, Q, and R. Okay, what is the question? State the transformation that takes T to P. Which transformation takes T to P? As you see, T didn't change direction, T didn't flip, so it means it's just translation. And we have to describe the translation. Look, T is moved like this to be P. The translation, we can focus on one corner of the triangle, which is better. Then it's moved 1, 2, 3, 4 squares to the right and 2 squares up. So the first one is translation. It is 4 squares right and 2 squares up. We can say 4 to the x direction and 2 to the y direction. Since the 4 is positive, means to the right, and the 2 is positive, means up. If we say negative 2 in the y direction, means 2 steps down. But basically we can say 4 units right, 2 units up. Easier. State the transformation that takes T to Q. Which transformation can take T to Q? As you see, Q is flipped comparing to T. Well, it means some reflection must happen. Then this corner is this one. They are corresponding ones. They are the same corner. How many squares are between them? 1, 2, 3, 4. It means the mirror line must be here. And here, y is equal to -1. To describe this transformation, we say it is reflection. And whenever you say reflection, you have to mention the mirror line. The mirror line is y equal to -1. Y is equal to -1 is the mirror line for this reflection that takes T to Q. And state the transformation that takes T to R. T goes to R by rotation, and the rotation is like this. So it is anti-clockwise because clock is always going from 12 to 1. But this one is opposite the direction of the clock, so it's anti-clockwise. And where is the center of the rotation? It is the center of the rotation. Using a tracing paper for this one is very good. It makes it so easier. Otherwise, it's anti-clockwise. It is 90 degrees. How you know it's 90 degrees? Because this line is horizontal here. But in the image it is vertical, so it means it's 90 degrees, anti-clockwise, and the center is 0, 0. This angle is 90 degrees. Now we have this triangle T, and we need to translate it by 8, 2. The first number stands for x, the second number stands for y. Since this 8 is positive, it means we need to go to the right side, because on the right side of x-axis the numbers are positive, on the left side the numbers are negative. So whenever you see a positive number here, it means 8 units to the right, because right side are positive numbers on x-axis. Then to translate, we focus on one point, and let's move this point 8 steps to the right, and then the 2, which represents y, is also positive, means 2 steps up. Now let's move this corner 8 steps to the right and 2 steps up. Remember, we need to count the spaces here. We don't count the corners, we count the spaces. So here 1, 2, 3, 4, 5, 6, 7, 8. This is not the answer because we need to go up 2 steps. Then 1, 2. This corner that we marked here comes here. Now throughout this point we can get the other 2. This point is just 2 steps on the left side on this one. So 2 steps on the left, we get this point. And this point is 3 steps above this point, perpendicularly. Then this point was this one, the second one is here. Go up 3 steps. Now we got the perfect copy of this triangle T, translated 8 steps to the right and 2 steps up. Now by joining these 3 points by straight lines, we will get triangle T, and we have to label A. Part B, triangle T should be rotated 180 degrees through the point 1 and 0. Point 1 and 0 is right here, and triangle T, it will be rotated 180 degrees. It will come here and it will be upside down. Then to do this, it's better to use tracing paper, or we can do it like this. Since it's 180 degrees, direction doesn't matter. If we go clockwise or anti-clockwise, we will go to the same position. That's why whenever rotation is about 180 degrees, the direction will not be mentioned, only the center. Now, this corner, this point is 3 step, and here 1, so 1, 3. It will come here. This point will come here, and then 2 steps away and 3 steps down is B. Now we need a single transformation that can translate A directly to B. So this is rotation 180 degrees about this point. Averages and spread is the topic for the next lesson. Basically mean, mode, median, and range. I hope you found it useful. Thank you for watching.